Now onto the last one in the series. Thank you for being with us all through the series. This question is not complete. I guess that question we wrote the question on it here. The last one in the series, number 18. One of the roots of the quadratic equation ax squared plus bx plus c equal to 0 is the square of the other. Prove that this statement is true. Also, prove also that this condition, that if this condition is satisfied, that is, if this statement is true, then one of its roots is this. So we need to prove the first before going to the second, because the first is a condition that must be satisfied before the second before we think of the second. The first must be satisfied because it said prove also that if this one is not satisfied, we don't continue with it. But if you are able to satisfy this, then we'll continue with this. Now, but don't forget, we said the solution now. Let the roots of the equation, normally the basic idea we know to be alpha and beta, but it said one is square of the other. So if alpha, we set alpha to be equal to r, then beta will be square of alpha, which is what? Square of r, as one root is the square of the other. Now, what is alpha plus beta from the standard quadratic equation? They give us the standard quadratic equation ax squared plus bx plus c equal to 0 in what we have here. So our alpha plus beta is going to be minus b over a. Our alpha beta is going to be c over a. That's what we wrote here. Alpha plus beta minus b over a. And you don't forget, alpha is r, beta is what? R squared. That will be r plus r squared equals minus b over a. So from here, just like what we did in number 17, what we just need to do is just to make b the subject of the formula. So cross multiply, or a will multiply the whole of this. So that will be minus b equals what? A into r plus r squared. Now the variable side by minus, or take the minus to the other side. So b is going to be what? Minus a. Now we factorized r. We factored r. R is here, so we can say minus a r. The minus here brought it to this side. So you can see that will be minus ar into 1 plus r, or r plus 1, because we factored r. So here we are left with 1, here we are left with r. So that's what we have here. So that is what? Our b. B equals this. Note that we need to get a, b, c. We can only prove this statement by knowing a, b, c, and then substituting it here. See if the left hand side will match the right hand side. If they match, that's a well done job. If they don't match, it's not a well done job, bro. So we continue. So alpha beta is what? C over a. Of course, don't forget, alpha is r, beta is r squared. That will be r times r squared equals c over a. So from here, we can say r cubed equals c over a. C is going to be what? A times r cubed. That's c. Note that too. And a equals a. Since this one is not fraction, you know the other one was fraction, so we needed the denominator to be equal to the numerator. For the number 17, please follow the series, go and check that. That's a very cool and amazing video too. But this one is not fraction, we can just say a equals a. So from there, what do we want to prove? We want to prove that this equals this. So we check the LHS first. So we deal with what is inside the bracket, 3ac. That will be 3 times a is a and c is z. So that's how we get 3 times a r cubed. Substituting ABC into this relation. Substitute ABC into this relation, squaring b accordingly. So that will be 3a times ar cubed. You're seeing it, a is a. That's how we got it. 3a is a. C is what? Ar cubed. That's how we got it. Minus. What's our b? So put it here, then square. Square here will make the sign positive. This one inside the bracket will be positive, so the minus here will still be maintained. You need to deal with this square first before you remove this bracket. So it's not a minus sign, minus equal to plus thing. No, first deal with the bracket first. So a will be squared, r will be squared, and everything inside this place too will be squared. Are we together? So the next thing we have is what? Still at the right hand side, of course. I believe you don't have issues with this side. So this will be 3a square r cubed minus a square r square. We expanded this. That is what? R squared plus 2r plus 1. What we did there was just r plus 1 times r plus 1. So the next thing, we factored out something. Something is common to everything, a square. So we brought out the a square. Here we left with what? 3r cubed. And then there's a minus r that will minus r squared that will multiply everything here. minus r squared times r squared minus r raised power 4 minus r squared times 2r minus 2r raised power 3 minus r squared times 1 minus r squared. Are we together? Meaning that we can conclude, don't forget this is 3r cubed minus 2r squared, that's r cubed. This will be negative, this will be negative. So that's the conclusion we draw. 3ac minus b squared equals all of this. Are we together? Now, that's what we get. But don't forget there's still a b in the question, b times all of these. So we then did b. Don't forget b from the question is what? B is minus ar into r plus 1. So we let that minus ar into r plus 1. So we are here now b into 3ac minus b squared. So minus ar into r plus 1 times what we get for this one. Are we together? So, cool. Since it's multiplication, we don't need to stress itself at that. Very easy thing. So this is going to be what? Open and remove these brackets. It's still multiplication. Everything is multiplying each other, so we don't need to put any bracket there. Don't magnify it too much. So from there, what do we have? We have a times a squared, that's a raised to power 3. R times r squared, r raised to power 3, and then this one times this one. Now, we needed to simplify this. Simplifying this to see what it will lead to. We needed to simplify this to see what it will lead to because we don't want to create an issue for ourselves. I get what I'm saying? So to simplify that, we did that here. Because we want to see, we reduce it to the least term. So simplifying this, this was what we get before. We needed to simplify this. So we say this bracket times this bracket. We use this one to multiply this. So that will be r times the whole of what we have here. And then 1 times the whole of what we have here. Are we together? I believe my people are with me. And then, I believe you don't make the mistake. Don't forget, don't say, where do we get this guy here? This one is r cubed minus r squared minus r raised power 4, this part. So we can actually say what? Factorize r squared. Factorize, since there's r squared can go here, r squared can go here, r squared can go here. So that's how we get the a squared r squared times the whole of this. So don't get that wrong. So we factorized r squared here. We factorized r squared. So r3, when you are in factorization, you divide each of these terms by what you brought out. So I divided this one by r squared. So that will be 3 minus 1, 1. 2 minus 2, that's raised power 0. R raised power 0 is 1. 4 minus 2 by law of indices. So that's how we got this. Factorization. So now simplifying that point, simplifying it. So that will be r will multiply everything here plus 1 will multiply everything here. Do you understand? So r times all of these, that will be r squared minus r cubed. That's what we have here, and then plus r minus 1 minus r squared. So r squared minus r squared off, minus r plus r off. We are left with what? Minus r cubed minus 1. So I brought the one before this. So that's minus r cubed minus 1 minus 1 minus r cubed. But don't forget, in the question, this b squared into 3ac minus b squared is what? Minus a cubed r cubed. So I can actually bring the minus. Don't forget, when it is multiplication, in multiplication, it is commutative, it is associative. So that somebody writes 2 times minus 3 times 4 is the same as minus 2 times 3 times 4. So that's how we felt, okay, this minus can actually come and play its role here. All together here now. So, and even here, say what we did here, minus is common to everything, right? Minus is common to everything. So we factored out the minus here. Minus is here, minus is here. Don't forget, this one here, these two, when we expanded this, we got this. Now we factored out the minus. So we are left with what? Minus into, this will be positive, this will be positive. Then the minus here times the minus here is positive. Meaning that our b into 3ac minus b squared led to what? A cube, r cube, into bracket 1 plus r cube. Do you get that? So this is what we get for the LHS. Now trying the right hand side now. Right hand side, it is ac into a plus c. Don't forget, a is still a, c is ar cube, and A is A, C is AR cube. Are you there? So A times A square and R cube into bracket what? A plus AR cube. One thing is common to these two. What is that? A. So that will be A into bracket 1 plus R cube. A square times A cube, R cube into 1 plus R cube. This is what we get for the right hand side. This is the right hand side. This is the left hand side. Is there any difference? Are you seeing it? Are you seeing it? Right hand side, left hand side. Right hand side, left hand side. Are they equal? I think they are equal. They are 100% equal. So we say since the left hand side equals the right hand side, the statement is true. Meaning that this question, this part here, we've been able to prove it. Left hand side equals right hand side. So that's the first part. Now the second part, they now said we need to prove that one of the roots is this. So what do? Just invite, don't forget, again, B is what? All of this. We got that before. B from here. B from here, we just import B, C, and A from here. So B is minus AR into R plus 1, A is A, and C is AR cube. So we want to test, we want to see if that is true. B minus C over B minus A. B is what? Minus AR into R plus 1, minus C is what? AR cube. All over B again, and A is A. The minus here from the question, minus. But B is having minus from its own itself. B itself is a negative or negative stuff. So that's where you get it, this one from and this one from. Can we continue, please? God bless you. So, right about it. Now, so this is what we got. We open the bracket, R times this, R square, R times 1, R. Again, at the denominator, R times this, R square, R times 1, R. So the next thing we do is what? To factor out the minus A. Minus A is common to both terms here. Minus A is common to both terms. So that will be minus A into bracket. You are left with R square plus R. Then minus is out. This should now be positive, R cube. Over the denominator to minus A is common. So we are left with R square plus R plus 1. So minus A cancels minus A. So what do you have left? This one over this one again. Something is common to this. R is common to everything. So we factored out the R into R. R squared divided by R is R. R divided by R is 1. R cubed divided by R is what? R squared. All over R squared plus R plus 1. If you reorder this, you get it this way. And this, they are the same thing, cancel out. So meaning that B minus C over B minus A is actually R. B minus C over B minus A is actually R. Now, how do we now know if it is truly a 10? Don't forget, we said from the question, let the root be alpha and beta, and let alpha be R. So if you eventually get R here, meaning that, in fact, B minus C over B minus A is the first 10. Is one of the 10. Do you understand? Meaning that the statement is correct. Thank you very much for being part of this series. Do like, subscribe to this channel. Turn on the notification bell in case we have other cool and amazing videos like this, educational videos. This is home of mathematics. All we do here is mathematics. Don't miss out. Always be there. Have fun with maths. And if there's anything, any topic you want us to help you demystify, any topic disturbing you from any level, just write the topic down, then let's see how we can help you with it. Thank you.